Welcome back, everyone. Strap yourselves in for rapid fire Blitz student presentations. I'd like to call on Dr. Maria Jelnik from La Trobe University and Dr. Jonathan Maynard from the Murdoch Children's Research to chair the next session.
Thanks, Andy. I'm Dr. Jonathan Maynard from the Murdoch Children's Research Institute. It's a very exciting session we have coming up, the Student Blitz presentation. So we'll get right into it. The students, just a reminder that you have 3 minutes and then we'll have 2 minutes for questions. So the first presenter, maybe you can start sharing your screen, is Vivian Tran from La Trobe University. And she'll be speaking on females are protected against vascular complications in obesity.
Okay, am I ready
so
to
take
start?
it away. Yeah, go for it, Vivian. Thank you.
Obesity is a complex disease that affects 2 out of 3 Australians, 70% of which are males, as they favourably gain more visceral adipose tissue, of which includes, and is the focus of my study, perivascular adipose tissue, or PVAT. So in this study on the right-hand side here, we see that in the blue graph in lean mice, vascular function remained the same whether the PVAT was left on or off. In the red graph, however, in obese mice, when the PVAT was left on, it resulted in poor vascular function. This emphasizes that there is a dysfunctional role of the PVAT that is known to contribute to endothelial dysfunction. So despite knowing that there is a phenotypic switch of the PVAT in obesity, the pathophysiology of this is still unclear, which leads me to my project, where we hypothesize that the development of obesity in male mice will result in endothelial dysfunction. We aim to characterize the aortic immune cell profile and endothelial function in a mouse model of obesity. So we used C57 black 6 male and female mice, where at 5 weeks they either remained on their normal chow diet or placed on a high-fat, high-GI diet for 10 weeks, where we were able to collect the weekly body weight measurements, as well as fortnightly fasting blood glucose measures. At the end of the 10 weeks, we collected the aorta for flow cytometry and wire myography. So with the physiological measurements, we found that in our high-fat diet-fed male mice, there was a significant weight gain that started at week 5, as well as high levels of fasting blood glucose compared to their normal chow counterparts. In females, however, we see that there is a delayed response in the development of obesity that started at week 8 and correlated to the high levels of fasting blood glucose. However, this difference was diminished by week 10. Next, when we look at the endothelin-dependent relaxation in these concentration response curves to acetylcholine, we see that the relaxation remains unchanged both between the diet and the two sexes. But if we look a little bit closer at the maximal relaxation response, we see that there is a decrease in the percentage of relaxation in the high-fat diet mice, indicating that males in particular have impaired endothelin-dependent relaxation. Next, when we look at the immune cells, we see that there is a response in the innate immune system. Specifically, we see a decrease in the number of macrophages as well as inflammatory monocytes only in the females, which is interesting because we don't see any changes in immune cell infiltration in the males. So in summary, our male mice developed obesity, had hypoglycemia, and even though had no changes in immune cell infiltration, showed evidence of endothelial dysfunction. Females, on the other hand, had delayed obesity, a decrease in the amount of inflammatory monocytes, but were protected against this vascular dysfunction. So this suggests that there is a sex-specific protection that we see only in the females. So in future, we hope to perform immunohistochemistry so we can better localize where these immune cells are within the aorta, so we have a better understanding of these sex differences. Thank you.
Thank you, Vivian. So do we have any questions? You can either put your hand up or type in the chat and I'll read out the question. Matt Nelson or Snelson?
Thanks.
You can unmute.
Really good presentation. I'm just going to ask about the weight differences that you saw. Was there any difference in food intake, and whether if they're eating similar amounts, whether there's any differences in metabolism?
Yeah, so with the diet that we did use, it was really hard for us to measure their weight because we started to measure how much they were eating and how much they were drinking. But because the diet was really crumbly, and unless it was frozen, it would just fall apart. And then, so it was really hard to measure how much they were eating because in addition to that, they were also shredding the diet because it breaks apart so easily. So it was hard to determine whether the females were lighter because they were eating less or not. But that could still be a potential as well.
Thanks, Vivian. Anastasia has a question.
Yep.
Nice presentation, Vivian. These are young mice, are they? And considering older females put on weight, what would you speculate?
So it's been shown in other studies before that the older the mouse, we see that switch in the hormone level. So they'll switch to a more male phenotype in terms of hormone levels, where they'll lose that estrogen protection, which we speculate is why they're protected against this vascular dysfunction. So I guess why we start our females so early is that we want to see if there's potential for them to develop obesity even at a young age, despite the hormone levels we see. If that makes sense.
Okay, thank you, Vivian. Thanks for answering those questions. We'll move on.